In this video, we are going to continue to talk about molar mass, and we're going to see its uses in calculations. So one of the things that we lastly talked about in the previous video was how to calculate the molar mass for a particular compound. So here in part C of the in-class worksheet, as you can see, we have 3 different compounds and you need to calculate their atomic mass or their molar mass. Understand that the numerical value for molar mass and atomic mass is the same. The only difference between the two is just the unit. For atomic mass, we utilize AMU. For molar mass, we need grams per mole. So I'm going to do the second one, potassium permanganate, as our example for this. So potassium permanganate has the chemical formula of KMnO4. So what this means is that we have 3 different elements in this compound. We have potassium, we have 1 of them. We have manganese, we have 1 of them. And when it comes to oxygen, we have 4 of them. So taking that into consideration, you will use potassium, manganese, and oxygen, and we're going to multiply that value times the atomic mass for each. So for potassium, we have 39.0983. For manganese, we have 54.938045, and for oxygen is 15.9994. So understand that coming from the periodic table, this is going to be AMU. So when we multiply it times the subscript that we have for the element in that compound, the first one is going to be 39.0983. The second one is 54.938045. And then the last one, 15.9994 times 4 is going to be 63.9977 AMU. Okay? Then we're going to add all of these values. And when we add these values, then we find a molar mass of 158.033945. Now understand that for the problem, when you look at the answer key, what you're going to observe is just 2 decimal places, because when I created the answer key, I utilized the periodic table from the textbook. So if I report it to the same number of sig figs that I have written before, if I say, hey, just round to 2 decimal places, then the final value is going to be 158.03 AMU, or 158.03 grams per mole. So now that we know how to calculate the molar mass, then let's utilize it in calculations. As you can see here, the first thing that we're going to learn to do is convert mass to moles of a particular compound. You could also do it for elements. But in this problem, as you can see, it states a box of salt, which is NaCl, contains 737 grams of NaCl. We're just trying to find the moles of NaCl in this box. Now, understand that as I mentioned before, remember that this is chemical quantities. So maybe in everyday life you don't utilize these, but if you're in the laboratory or doing experiments, these are the type of calculations that we have to do, because that is the values that we use for our measurements, because we are in a chemical world when we are in the laboratory. And then at times, the reactions we're going to see later in the chapter, they have molar relationship between them. And sometimes because our loading balances or top loading balances or analytical balances measuring grams, we need to do conversions between moles and grams. So for this particular problem, okay, what is given is going to be grams of a compound. What we need to find is moles of a compound. Okay, so understand that in this case we are going to be looking specifically at this area of my flow chart. What is given is moles of compound. What we need to find is grams of compound. So when we have this and we're going from, I did it backwards. Let me fix it. What is given is grams of compound. What we need to find is mole of compounds. I put it backwards, but now it's fixed. So for this problem, because we're going from grams to moles, we're going in this direction. We're going to be dividing, okay, by the molar mass, which is our conversion factor. And as you can see, I'm highlighting it in green. So that's our conversion factor. If we are giving moles of compound, which is the first thing that I wrote incorrectly, and I go to grams of compound, so understand that if we have to do this conversion, then we're going to be multiplying by that molar mass. So in this case, remember, this is what we need to do. So let's just set up the problem. I am given 737 grams of NaCl. And because I need to convert it to moles, I'm going to divide by the molar mass, okay? We just established how do we find the molar mass of a compound. So I'm just going to write it on top. So the molar mass of NaCl is going to be, if you take 1, multiply it times sodium, 1 times chlorine, and then you add those values. So sodium is 22.9898 and chlorine is going to be 35.453. So when I take my value and I round it to 3 sig figs, the molar mass of chlorine is going to be 58.443 grams per mole. So that's what I'm going to use as my conversion, okay? So remember, in 1 mole of NaCl, I have 58.443 grams of NaCl. Grams of NaCl cancel. And when I take 737 and divide it by 58.443, then we have to round that final answer to 3 sig figs, which is what is given. Then I find that the number of moles in that many grams, or in this box of salt specifically, is going to be 12.6 moles of NaCl. In the in-class worksheet, as you can see, we have 2 different problems. Now, understand that this conversion between grams and moles can be done for just elements or just compounds. So the one for just elements, as you can see, is the dotted line that I'm writing on the top. And the ones between compounds is going to be the one that I did in the bottom. So understand that the conversion factor is the same. It's still the molar mass. It's just that for the top one is element, because we are changing between an element, and then the bottom one is going to be the total mass for the compound itself. So in order to do this, I am going to actually do problem 1 as an example, because in problem 1 is where I am given moles of an element, but I need to find grams of an element. Okay, so I need to go this way, and when I do that, remember that we're going to multiply times the molar mass. So I write in the value that was given to me, which is 8.13 moles of neon, which is our element. And in this case, remember, I'm going to multiply times the molar mass of neon, which is 20.1797 grams of neon in 1 mole of neon. The unit of moles of neon cancel, and then my final answer needs to be expressed in 3 sig figs, which is 164 grams of neon. Now, because now we know how to calculate molar mass and we know all of these relationships, we can even tell, for example, if we have a particular compound, how many grams of a particular element we have within that compound. Okay, and that's the problem that we have here. In this problem, we are actually calculating the mass of an element within a given mass of a compound. Okay, so if I utilize my flowchart, which is in the bottom left corner of the slide, as you can see here, I am given, or let me read the problem first. It says 1 cup of cheddar cheese contains 4.05 grams of table salt. How many grams of sodium are in 1 cup of cheddar cheese? Now, when it comes to this is very relevant to everyday life, because one of the things is that it is known that sodium is a very important ion that is necessary for cellular function. Now, if you consume it in excess, which the daily value of sodium that should be consumed is actually less than 2 grams. But if you consume on a daily basis more than 2 grams, it is known that it can have very serious repercussions to health, including high blood pressure, water retention, and then, complications with that. So at times in our diet, and when you look at food labels, one of the things that it is calculated and it tells you is like, hey, per serving, this is how much sodium you have. And it's because they're doing this calculation in terms of separating, even though table salt has sodium and chlorine, how much sodium in particular that will have. So with the problem in hand, I know that I am given grams of compound, and what I need to find is going to be grams of element. Now, as you can see, there is not a direct route. There's not like a one conversion thing. When it comes to this, which I'm going to highlight the whole path in blue, we need to go through this whole process, which, as you can see here, it establishes in the direction that we're doing this problem that we're going to do 1, 2, 3 conversions. So we have first conversion factor, second conversion factor, third conversion factor. So when we are doing this problem, always, we're going to have 3 conversion factors. So first we're going to write what is given to us. That in this case is going to be 4.05 grams of sodium chloride. And we know that in order to find the grams of sodium, we need 3 conversions. Okay? Now, in the first one, as you can see here, we're going to be utilizing the molar mass of the compound to find the moles of the compound. So I know that if I'm going left to right, specifically, I'm going to divide by the molar mass. So I'm just going to write it here. Division by that molar mass. So that means that in a previous problem, I already calculated the molar mass of sodium chloride is right here. So 58.443. So 58.443 58.443 grams of NaCl and 1 mole of NaCl. So I'm done with the first conversion. In the second conversion, I'm going to utilize the formula subscript. So what does that mean? That I'm going to establish that in 1 mole of compound, I'm going to utilize the subscripts to guide me to how many moles of sodium do I have. So in this case, it's going to be 1 because the subscript of sodium, it is 1. And then in the last step of here, I'm going to use the molar mass of sodium specifically to find the grams of sodium. So I'm going to say in 1 mole of sodium, I have it specifically 22.9898 grams of sodium. Okay? So if I start canceling units, grams of sodium chloride with grams of sodium chloride, moles of sodium chloride with moles of sodium chloride, moles of sodium with moles of sodium. So my final answer needs to be reported in 3 significant figures, and the units are going to be grams of sodium. So when I do this problem, I'm going to multiply 4.05 times 1 times 1 times 22.9898, and then I'm going to divide all of that by the result of multiplying 58.443 times 1 times 1. And I find that if I round my calculator display to 3 sig figs, I'm going to find 1.59 grams of sodium. On our worksheet on part E, we have problems that have to do with the conversion of given the grams of a compound. How do we find the grams of an element? And as you can see here, I'm going to do problem 1, which says how many grams of oxygen are in 25.0 grams of carbon dioxide. So again, if we're utilizing our flow chart, this is what is given. This is what we need to find. We have 3 conversion factors: the molar mass of the compound, the formula subscripts, and the molar mass of my element. So let me just set up the problem. I'm going to write down the number that is given, 25.0 grams of CO2. In the first conversion, I'm going to find the molar mass of CO2, which it is 44.0095 grams of CO2 in 1 mole of CO2. I'm done with the first conversion. Second conversion, the formula subscript. I'm going to establish that in 1 mole of CO2, I have 2 moles of oxygen. I utilize my second conversion factor. And in the last one, I'm going to say 1 mole of oxygen is going to equal the molar mass of oxygen, which is 15.9994 grams of oxygen. So if I cancel my units, grams of CO2 cancel with grams of CO2, moles of CO2 cancel with moles of CO2, moles of oxygen cancel with moles of oxygen. So my final answer, rounded to 3 sig figs, is going to be 18.2 grams of oxygen. And this is how you do a problem in which you're given grams of a compound and you're trying to find grams of a particular element in that compound.